Now next is stoichiometric calculations. So we will follow the following steps for the stoichiometric calculations. So write down the steps. So very first, write down the balanced chemical equation. Write down the balanced chemical equation. So second step is write the relative number of moles or the relative masses of products and reactant so write the relative number of moles or the relative masses of products and reactants. Okay, so this will be the second step. Third step is, in case of gaseous substance, write down 22.4 liter at STP below the formula in place of 1 mole. So in case of a gaseous substance write down 22.4 liter at STP below the formula in place of 1 mole. Okay, now next is apply unitary method to make the required calculation. So apply unitary methods to make the required calculations. Okay, so these are the 4 steps to calculate stoichiometric calculations. First, write down the balanced chemical equation. Second is write the relative number of moles or masses of reactant and product. And next is write down the volume in case of gaseous reactant and gaseous product. And last one, apply unitary method to make required calculations. Now next is limiting reagent. So what is the meaning of limiting reagent? So simply we can say that the reagent which is present in any chemical reaction in a limited amount, or we can say in less amount, which will consume very soon. That is called as limiting reagent. So that reagent present in limited amount in a chemical reaction which consumes early called as limiting reagent. So next is limiting reagent, can call it LR. So we can write the definition of LR is the amount of the product formed that depends upon the reactant which has reacted completely. So this reactant is called the limiting reagent. So we can write the amount of the product formed that depends upon the reactant reactants which has reacted completely. So this reactant is called the limiting reagent. Okay, we can write the second definition. The reactant which get consumed limits the amount of product formed and is therefore called the limiting reagent. So we can write the reactant which gets consumes consumed limits the amount of product formed and is therefore called the limiting reagent. Okay, and the reactant which is not completely consumed is referred to as excess reactant. So we can write and the reactant and the reactant which is not completely consumed is referred is referred to as excess reagent. Means the reactant which is present in excess amount. Okay, so now next is how to find the limiting reagent. So we can choose the following steps. How to find limiting reagent. So first step we can write, divide the given moles of the reactant by the respective stoichiometric coefficient of that reactant. So first is divide the given moles of reactant by the respective stoichiometric coefficient of that reactant. Okay, and step 2 is see for which reactant this division come out to be minimum. The reactant having the minimum value is limiting reagent for you. So second step is see for which reactant this division come out to be minimum. The reactant having minimum value is limiting reagent for you. Okay, so we can write a simple formula to calculate limiting reagent. So we can write limiting reagent given coefficients This is divided by a stoichiometric coefficients. Stoichiometric coefficient. So this is the formula to get limiting reagent. So we can take an example. So write equation at NTP 40 ml of nitrogen, 40 ml of nitrogen reacts with hydrogen to give ammonia. Calculate the mass produced ammonia. Calculate the mass of produced ammonia, and given reaction is N2 plus thrice S2 equals to twice NH3 . Okay, so in this reaction, so very first we have written the step to calculate limiting reagent. So first, limiting reagent are those reagents which present in limited amount. We can say that which consumes early in a chemical reaction. So find out the limiting reagent. We have written two steps. So step 1, divide the given moles of the reactant by the respective stoichiometric coefficients. Okay, and second is see for which reactant this division come out to be minimum. That will be our limiting reagent. So here in this balance equation, 1 mole nitrogen react with thrice moles of hydrogen and it forms twice moles of ammonia. So this is the balance equation, and these are the stoichiometric coefficient of balance equation. And given coefficient is, question is given 40 ml of nitrogen which react hydrogen. Okay, so hydrogen in excess amount is present here, and we have to calculate mass produced of ammonia. So in this case, we can write according to balanced equation, 1 mole of nitrogen is equals to 22,400 ml. Okay, So in this case, if we write, this is the 1 mole, so 1 mole is 22400 ml produced here 34 gram ammonia. Okay, now we can use unitary method. So here if 22400 ml of nitrogen produced 34 gram of ammonia, so 1 ml of nitrogen will produce 34 as divided by 22400 gram of ammonia, and here 40 ml, which is given 40 ml of nitrogen will produced, so 34 is divided 22400 into 40, so we will get here 0.0607 gram of ammonia will be produced by 40 ml of nitrogen. Okay, so this is the simple way to calculate limiting reagent. Now next is different calculations which we have written earlier, like mass relationship, mass volume relationship, and volume relationship. So we will discuss all that one by one. So we are going to discuss first mass relationship. So we can write here type first mass relationship. So just write a question. What weight of sulfuric acid that is H2SO4 will be required to dissolve completely 3 gram magnesium carbonate. So this is our question. We have to calculate required weight of sulfuric acid to dissolve completely magnesium carbonate of 3 gram. So first write down the balanced chemical equation. So writing the equation, so equation will be MgCO3 reacts with H2SO4 and it will form magnesium sulfate plus CO2 plus H2O. So balance out this equation. So it seems already balanced equation. so no need to balance it. So here 1 mole of magnesium carbonate react with 1 mole of H2SO4, it will form 1 mole of magnesium sulfate, 1 mole of CO2 and 1 mole of H2O here. So we can write 1 mole of magnesium carbonate reacts with 1 mole of H2SO4. So 1 mole of magnesium carbonate required 1 mole of H2SO4. So in terms of weight, we can write 84 gram, which is the molecular weight of magnesium carbonate, required 98 gram of H2SO4. Now we can apply unitary method. So here 84 gram magnesium carbonate needed H2SO4 to completely dissolve is 98 gram. So 1 gram of magnesium carbonate requires H2SO4, that will be 98 by 84 gram, and 3 gram of magnesium carbonate requires, so that will be 98 and to 3, so we will get 3.7 gram of H2SO4 needed to completely dissolve magnesium, 3 gram of magnesium carbonate. Okay, now we can take another example. So we can write another question. Question is, how much potassium chlorate is needed to get enough oxygen for completely burning 84 liter of carbon monoxide at NTP. 84 liter of carbon monoxide at NTP. Okay, so question is, potassium chloride is needed to get enough oxygen for completely burning of 84 liter of CO at NTP. So very first write down the decomposition reaction of potassium chlorate. So we can write here KClO3 produced twice KCl plus thrice O2 and 2CO reacts with oxygen and form 2 CO2. So in this case, twice moles of KClO3 produce thrice moles of oxygen, and single mole of oxygen is required to completely burn twice mole of carbon monoxide. So we can write twice volume of CO, which required 1 volume of oxygen. So we can write 84 liter of carbon monoxide needed 42 liter of oxygen. So we can write 84 liter of carbon monoxide needed 42 liter of oxygen. So 3 into 22.4 liter O2 produced by 2 into 122.5 gram of KClO3. Okay, so 1 liter of O2 produced by, so 1 liter O2 produced by 2 into 122.5 divided by 3 into 22.4 liter means 4 gram of KClO3, and we required 42 liter of oxygen, so which is produced by 2 into 122.5 divided by 3 into 22.4 into 42. So we will get here 153.125 gram of KClO3. So required amount of KClO3 will be 153.125 gram. Now next type is mass volume relationship. So we can write type 2 mass volume relationship. So in case of mass volume relationship, you can write a question. So question is, at 25 degrees centigrade for complete combustion of 5 mole propane C3H8 propane, the required volume of O2 will be, the required volume of O2 will be. So solution of this question is C3H8 react with oxygen and it forms CO2 and here 4H2O. So this is the balance equation. 1 mole of propane react with 5 moles of oxygen and form thrice moles of CO2 and 4 moles of H2O. So in this question we have to calculate required volume of O2. So here 1 mole of propane required 5 moles of O2. So we can write 5 into 22.4 liter. Oxygen required by 1 mole of propane. So we can write it in this way: 1 mole propane required amount of oxygen is 5 into 22.4 liter. So 5 moles propane required amount of oxygen is 5 into 22.4 into 5. So we will get 560 liter oxygen. Okay, so we can use this unitary method to calculate mass volume relationship. We can take another example to understand the mass volume relationship. So write the next question. At 100 degrees centigrade for complete combustion of 6 gram ethane, the required volume of O2, the required volume of O2 and produced volume of CO2 and produced volume of CO2 will be. So we can write this. In this question, at 100 degrees centigrade for complete combustion of 6 gram of ethane, the required volume of O2 and produced volume of CO2. So very first step is write down the required chemical reaction. So we can write ethane reacts with oxygen on combustion, it form carbon dioxide and water. So balance out this equation. So we can write here 2. So this will be 4. If we write here 7, so we can write here 6. Okay, so this is the balance equation. So in this balance equation we can get the weight of this. So weight of this is 30 gram 2 into 30 gram, means we can say this is the 60 gram weight. So 60 gram of ethane required oxygen is 7 into 22.4 liter. Okay, so in this way we can calculate volume of oxygen. So here 7 into 22.4 liter of oxygen required. So we can write 60 gram ethane required O2 is 7 into 22.4 liter. So 1 gram of ethane required O2 is 7 into 22.4 by 60, and 6 gram ethane required O2 will be required O2 is, so we can write 7 into 22.4 divided by 60 into 6. So we can get here 15.68 liter oxygen required for the 6 gram of ethane. Now next is 60 gram of ethane produced 4 into 22.4 liter of CO2. So we can use here also unitary method. 60 gram ethane produced CO2 is 4 into 22.4 liter. So 1 gram ethane produced CO2 is 4 into 22.4 liter divided by 60, and 6 gram of C2H6 produced CO2 is 4 into 22.4 by 60 into 6. So we will get here 8.96 liter of CO2 produced. So this is the our answer. Now next is type third, which is volume relationship. So in case of volume relationship, we relate volumes of gases. So we can write type third volume relationship. So in case of volume relationship, we can write a question at 100 degrees centigrade for complete combustion of 5.6 liter of pentane C5H12 pentane, the produced volume of H2O and CO2 will be, okay. So in this case we have to write balance equation. So C5H12 reacts with oxygen and it forms CO2 and H2O. So balance equation here, 1 mole reacts with 8 mole of oxygen and it forms 5 moles of CO2 and 6 moles of H2O. So this is the balance equation. So by the stoichiometric coefficients of this equation, we will get 1 volume of pentane reacts with 8 volume of oxygen and it forms 5 volume of CO2 and 6 volume of water. So we can write 1 liter reacted with 8 liter of oxygen and it forms 5 liter of CO2 and 6 liter of water vapor. So now 5.6 liter, which is given in question. So 5.6 liter pentane reacts with 5.6 into 8 liter of oxygen and it forms 5.6 liter into 5 liter of CO2 and 5.6 into 6 liter of H2O. So we can write it 5.6 liter pentane produced 44.8 liter oxygen and it formed 28 liter CO2 and 33.6 liter H2O. So this is our answer. Produced CO2 and produced H2O. Okay, and so write down the next question is, we can write, so question is 12 liter of mixture, this is the last question, 12 liter of mixture of methane and propane on complete combustion gives 14 liter of CO2. So find out the composition of the mixture. So in this question volume of product is given and ask about the volume of reactant. So let's discuss this question. So we can write, let the volume of CH4 is X liter. So So let the volume of methane or CS4 is X liter, then volume of propane in the mixture, that will be 12 minus, so total mixture volume is 12 liters, so this will be 12 minus X liter. So this is the volume of propane. Now write the equation. If CS4 reacts with O2, it forms CO2 and H2O. If we balance it out, we can write 1, here 2, here 1, here also 2. Okay, so here 1 liter of methane produced 1 liter of CO2. So 1 liter of methane produced 1 liter of CO2. So similarly, X liter of methane produced X liter of CO2. Okay, now next write down the equation for propane. So propane react with oxygen, it also form CO2 and H2O. This is the reaction for complete combustion. If we balance it out, so here 1 mole of propane react with 5 mole of oxygen and it form 3 moles of CO2 and 4 moles of H2O. So we can write 1 liter of propane produced 3 liter of CO2. So similarly, 12 minus X liter of propane produced 3 into 12 minus X liter of O2. So in this questions, total produced CO2, here X liter and here is 3 into 12 minus X liter CO2. So total CO2 will be, so total CO2 produced by mixture is X plus 3 into 12 minus X, that will be equals to 14 liter. Okay, so we can write it 3 plus 36 minus 3x equals to 14. So here 2x equals to 22, so x equals to 11 liter. So volume of CS4, that will be X, that will be 11 liter, and volume of propane will be, that will be 12 minus X. So 12 minus 11, that will be equals to 1 liter. So 1 liter the volume of propane and 11 liter is the volume of methane. So in this way we can calculate a stoichiometric calculation in all 3 types, that will be mass-mass relationship, mass-volume relationship and volume-volume relationship. Okay, thank you.